What if I told you that you can control a car racing game without touching a keyboard or joystick by just flexing your muscles? Sounds crazy, right? So hello everyone, I am Ankit from Upside Down Labs, and today I am going to show you how you can control a car racing game in real time by using your muscle signals. In this project, we are using EMG signals to control a car racing game using muscle activity. An EMG or electromyography is the electrical signal generated by muscles when they move. We are using the BioAmp EXG pill and muscle BioAmp shield to capture the muscle signals from both arms. In our previous video, we used an Arduino UNO R4 with the earlier version of this kit and demonstrated the project using a Python script and an Arduino code. This kit now includes Arduino UNO R4 Minima, allowing you to build a more advanced version of this project by using only a single Arduino sketch, making it more simpler, more efficient, and easier to understand. Here is how it works. When you flex your muscles or do a gesture, the electrical activity of your muscles is recorded through the sensors and then it is converted to keyboard keys using the Arduino UNO R4 Minima. Let's go through the hardware requirements. A BioAmp EXG pill, muscle BioAmp shield, gel electrodes or muscle BioAmp band, new prep skin preparation gel, alcohol swab, BioAmp cable, TEMA cable, Arduino UNO R4 Minima, USB to Type-C cable, laptop. You can get all this in DIY Neuroscience Kit Pro from Upside Down Labs, for which the link is provided in the description. For the software, you just need Arduino IDE, which you can download from the link given in the description. Now let's do setup and connection. First, tack the muscle BioAmp shield properly on the top of the Arduino board. Now connect the BioAmp EXG pill to the A2 port of muscle BioAmp shield using the 3-pin TEMA cable. Connect the BioAmp cable V3 to the BioAmp EXG pill and another BioAmp cable V3 to the muscle BioAmp shield by inserting them into their respective connectors. At this point, the hardware setup is complete. The next step is to prepare the skin. Now let's prepare our skin, as it is a crucial step to get the clean signal recording. Apply a small amount of new prep skin preparation gel on the areas where the electrode will be placed. Rub the area gently to remove the dead skin cells and improve conductivity. After that, clean the skin using alcohol swab to remove any dirt or oil. Now let's jump into the electrode placement. For the left arm, connect the BioAmp cable from the BioAmp EXG pill to the gel electrodes. Now peel the electrodes from the plastic pack. On the left forearm, near the ulnar nerve, connect black wire to the negative terminal. Connect the red wire to the positive terminal. Place the reference electrode at the back of your palm or any bony part. For the right arm, connect the BioAmp cable from the muscle BioAmp shield to the gel electrodes. Peel them off. On the right forearm near the ulnar nerve and place the black wire to the negative terminal. Connect the red wire to the positive terminal and place the electrode at the back of your palm. Besides these electrode placement, you can also record EMG signals from other muscles such as biceps, triceps, legs or jaw, depending on your application. For more detailed placement guide, you can check out our documentation, for which the link is provided in the description. Now let's upload the code. Connect the Arduino R4 Minima to your laptop using the USB to Type-C cable. Open Arduino IDE, copy the code from the GitHub repository, install the Arduino UNO R4 package, go to Tools, then click on Board, then click on Boards Manager and search for Arduino UNO R4 board and install the latest version. And select the Arduino UNO R4 Minima. Go to Tools, click on Port, then select the correct COM port. Upload the code to the Arduino. For the best signal quality, make sure your laptop is not connected to a charger and try to stay away from the nearby AC powered appliance. Now let's move to the calibration step. If the keyboard controls are not triggering properly, open the code and comment the following line. Upload the code to the Arduino again. Open the serial monitor and flex your right hand muscle several times while observing the values. You will notice that the values on the left column on the serial monitor changes significantly during right hand muscle contraction, while the right column remains relatively stable. Note the maximum peak value reached during a strong muscle contraction. This peak value will use to set the envelope 1 threshold. Next, flex your left hand muscle several times while observing the value. This time, the value on the right column on the serial monitor changes significantly, while the left column remains relatively stable. Note the maximum peak value reached during a strong muscle contraction. This peak value will be used to set the envelope 2 threshold. Once you have the peak values for both channels, set envelope 1 threshold and envelope 2 threshold to approximately 60 to 70% of your corresponding peak values. Now, As you are done with your connection and have uploaded the code, you can start playing your car racing game. And just like that, your muscles are controlling car racing game. No controller, no keyboard, just biopotential signals converted into game input. So that was our EMG controlled car racing system. This project demonstrates how biopotential signals like EMG opens the door to muscle control gaming, future human computer interaction system. If you enjoyed the video, make sure to leave a like, share and subscribe to the Upside Down Labs channel. I'll see you in the next video. Until then, keep tinkering.